Hi everyone. So welcome to this first supplementary video. Till now in the first week of classes, we have discussed the concepts of units and dimensions, properties of fluids like density, viscosity, surface tension, and so on. So in your homework one, problem one, you see that you'll be asked to calculate dimensions and units and so on. So the idea behind the supplementary video is to give you a little bit more practice on that subject. So let's do a problem to understand how to apply that in case there is any confusion. So you're given that there is a symbol E, and we haven't defined what E is, and that E is mu gamma dot square. And so recall that we've discussed mu is viscosity, and then gamma dot is shear rate. Okay, and this is something we have defined in the class. And you've been asked to find the units and dimensions of E and what is the physical meaning of E. Okay, so your homework problem is similar, but it goes on something like non-Newtonian fluids and so on. But the idea is the same. So that's why this will help you get some additional practice. So let's begin on how to think about this. So I'll give you two different approaches and you can take either of them, and it doesn't matter, which approach you choose. The idea is to better understand, like how to apply dimensions and units. So let's take the first approach. Approach one, where you say, well, okay, I want to find the units. I know the units of mu are kilogram per meter second. So remember that this is something we had derived in class. So you say units of kilogram of mu are kilogram per meter second, and then units of gamma dot are second inverse or 1 by second. You can say 1 by second or second inverse, either is fine. And so units of E would be similar to kg per meter second times 1 by second square. Okay, so this comes from the mu part, this comes from the gamma dot square part. Now, one note, something that you should remember is that this gamma square, let me choose a different color, maybe here, gamma square here, this square does not have any units. Okay, so exponents don't have units. So you just simply, you can never have an exponent with a unit. So you just simply square the unit. So in this case, the power is 2, but the exponent is 2. So simply square it. If it would be 3, you will take, a cube and so on. So essentially from this answer, you get something like a kg per meter second cube. Okay. So that is one approach. And from dimensions, you remember dimensions are always in MLT. And so this becomes mass length inverse time third inverse. Okay. So this is one approach, and it works. It's simple, but obviously it needs some information. And that information is that you have to remember the units of mu or viscosity. So you may or may not remember them. And so there are ways you can actually make your life a little easier. And so just to give you some idea of how we can go about this problem, but from a second approach, which is a little bit more physical approach. And some of this takes practice. So don't worry, if right away you couldn't recall some of these things. This takes practice. And as we go along in the course, you will get used to, some of these parts. By the way, we are just solving part A right now. Okay. So the second part, second approach is like this, goes like this. So, and hopefully you can see this approach too. Is that I have been given that E is equal to mu gamma dot square, right? So this is my E, but I also know that mu gamma dot is actually tau, right? This is the shear stress. So this is something we had learned in class, that viscosity times shear rate is shear stress, tau, right? So instead of directly saying, oh, I know the value of mu, let's say I don't know the value of mu. So I say it's tau, and then I do a gamma dot. And in this case, it becomes, and tau is force per unit area. This is force per unit area. And then I have gamma dot. So so hopefully sort of following this, so this is force per unit area, because this is tau, and then this is the remaining one gamma dot is left over. Now, force we know is mass times acceleration. So this becomes mass times acceleration. So mass is kg meter per second square divided by meter square here. Okay. So mass times acceleration, which is a meter per second square, and then gamma dot is second inverse. And even if you don't remember, or 1 by second, if you don't remember gamma dot's formula as well, always remember that gamma dot was du by dy, right? So change in velocity by change in length. Velocity was meter per second, and delta y was meter. So that's why we got 1 by second. Okay. And so from here, if you do it, you basically get the answer to be kg per meter second cube. And also the dimensions become ml minus 1, t minus 3. So hopefully you can see that both of the approaches give the right answer. Either of the approaches is fine. Again, don't worry. Oh, don't worry about forgetting the units of viscosity or shear rate. These things will become second nature to you as you go along in the course. But in general, like, it's good to sort of recall using these problems. What is the unit of viscosity, what is the unit of shear rate, and so on. And slowly, you will learn. But hopefully, you can see that sometimes recalling, mu gamma dot is tau can help you. So, it can kind of help you see, what are the units and dimensions of different variables. So both of the approach give you the same answer. In your homework problem, you have exponents which are n, could be fractional as well. So that is something you will do in your homework, and we'll give you more practice. The second part of this problem, and this is not something you will do too often, I just wanted to show you here, is what is the physical meaning of E? And that's sort of a little confusing, right? Because how do I extract meaning from something that, it's just a number mu gamma dot square? How do I extract meaning? And the answer really goes in trying to sort of see what the units are. Can we make any sense of it? So let's say B, one approach is B. We know B is kg per meter second cube. So we know the units are these. So how do I make any sense of this? Is just such a strange number. Like, how do I make any sense of this? And to do that, now I will start to sort of go a little bit further back into the system. So let's do that. So what I'm trying to say is, you would agree that I can call this as kg meter per second square by meter square by 1 by second. Okay, so this is how, this was my force. So this was my part from here, force, right? This was my area here, and this is my gamma dot 1 by second here. Okay, so this is my force per meter square by 1 by second. So this is force per meter square into 1 by second. So yeah, there is some meaning there that force per meter square is stress times gamma dot, but overall that doesn't really give any physical meaning. However, I can remember something else, is that I can say this is force times meter by meter cube into 1 by second. Okay, so I can say this is force times meter by meter cube into 1 by second. And please don't worry about how I'm doing this. This is just to show you some of the art behind this sort of units and dimensions. This is something you will not be expected to do in your exams or your homework. This is just something out of, I'm just trying to show you how you can manipulate some of these variables, and they can lead to a lot of insight. Okay, so don't worry about, okay, oh, I couldn't do this. This is just to sort of encourage you to see sometimes patterns that you may not be able to notice otherwise. Okay, and then this force times length is energy, right? So essentially this is energy, or rather joule, let's say joule, simply joule by meter cube. And then I have 1 by second, and then joule by second is watt per meter cube. So this is another way to think about this number. E is actually, this is power density. Power, which is watt per unit volume. And so this is power density. Okay. It's a beautiful sort of way to see how you can connect. So how did we do this? Is we did this by saying tau is mu gamma dot. So this was the whole idea here. And then basically from there, we went from force to energy or joules, because we know that. And from that, that's why this meter square became meter cube, because I multiplied and divided by m. So I converted that force to energy, and then I used that 1/2 from the gamma dot as to convert from joules to watt. So essentially, this is power density, or the rate of change of energy per unit volume. So changing rate means per unit time, right? So rate of change of energy, which is power, per unit volume. So it's power density. And this value that you are seeing here, mu gamma dot square, is actually known as the viscous dissipation. So this is the change, the energy you lose per unit time, per unit volume. So power per unit volume. Okay. So hopefully this video was helpful to see you get some additional practice for dimension analysis in units. And then hopefully this will help you with homework 1, problem 1. And then I look forward to seeing you in the next video. Bye-bye.